Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this, but I'm going to title it how I title the title. But what I am sure of is our one goal for the day. And our first and only goal is to solve and check two-step equations. We're going to combine the one-step methods in a particular order to accomplish this. So before I continue on the board, I want to just give an overview of where we're at. So far, we've learned about 4 one-step moves. Solve by adding, solve by subtracting, solve by multiplying, solve by dividing. Now remember, the series of lessons is going to answer the question that a student asked me many years ago when solving equations. How do I know what to do first? How do I know what to do next? And it was a wonderful question. It really forced me to reevaluate how I was teaching equations. I just used to write equations on the board and solve them, and I didn't realize that some students didn't know where to start. So in this series of lessons, I'm trying to address that. And when the series of lessons are over, we will have the 6 steps to solve any equation, and we can follow them and solve them successfully. So here we're going to start to see an ordering of the 4 one-steps so that we can solve 2 steps. All right, and I have our preliminary ordering. And so the first thing we're going to try and do is we're going to eliminate fractions by multiplying everyone by the denominator. So that's the first thing we look for. Do I have a fraction? The second thing we look for is we're going to add or subtract away a number from the variable side of the equal sign. The clue for this is I have a plus or minus between the number and a variable. And our third step is going to be to divide away a number from the variable side of the equal sign. That means that there's nothing between the number and the variable. Now, step 2 is 2 of the 4 steps, adding or subtracting. So we do have our 4 one-steps here. So let me go ahead and just show you how I would use this. And hopefully this helps you. And if you were struggling with the question, how do I know what to do first? How do I know what to do next? This will begin to answer that question. Okay, so the first problem, I want to solve and check 2x minus 3 is equal to 11. So what I'm going to do is I'm just going to write a 1, 2, and 3 next to this representing the steps. And I'm going to go through them in order. If I have it, I do it. If I don't, I move on. All right, step 1. Can I eliminate a fraction by multiplying everyone by the denominator? There's no fractions in here, so I can't do step 1. Step 2. Can I add or subtract away a number from the variable side of the equal sign? Meaning that I have a plus or minus between a number and a variable. Well, I do have a minus between a number and a variable, so I can do step 2. And I need to make this minus 3 go away. So what I'm going to do is I'm going to add 3 to both sides. Plus 3, plus 3. I can cancel that out. The 2x drops down. 2x is equal to 11 and 3. That gets me to 14. Now I'm to my last step. Can I divide away a number from the variable side of the equal sign? Meaning that there's nothing between a number and a variable. There's nothing between the 2 and the x, so I can divide that away. I'll divide both sides by 2. And I get that, let's see, that cancels out, and I get that 2 goes into 14 7 times. So I get that x is equal to 7. So I've solved it because I've gotten x by itself. Now I need to check this. And remember, when we check, we always go back to the original problem and replace the x with our value and work it out. So my original problem was 2x minus 3 equals 7. You must use the original. Now what I'm going to do is I'm going to replace my x with a 7. And whenever you replace, you have to put a parenthesis. Oh, it's not 7, it's 11. I didn't write the original equation right. There we go, okay. So here I have 2 7s, which gets me to a 14. I have a 14 minus 3, which gets me to 11. And 11 equals to 11, and that's a true statement. So I've got the correct solution to that equation. So this is me using the ordering of our 1 steps to solve 2 steps. And hopefully you're seeing an organic growth of the way that we solve. Okay, on to the next problem. 2 is equal to 4 plus x over 3. Again, I'm going to write my list of steps. 1, 2, and 3. And so let me just see if I have step 1. Eliminate fractions by multiplying everyone by the denominator. Everyone means I multiply you and you and you by the denominator because I have a fraction. So what I'm going to do is I'm going to write a 3 next to you. I'm going to write a 3 next to you, and I'm going to write a 3 next to you. Now notice in my first problem when I had a number in the numerator and the same number in the denominator, I crossed it out. That's what this first step allows me to do right here. I eliminated the fraction. So now we're going to have 6, because it's 3 2's, is equal to 12 plus, now my 3's canceled and I'm just left with an x. Now let's see if I have the second step. Can I add or subtract away a number from the variable side of the equal sign? So that means I have a plus sign between a number and a variable. I do have that. I do have that. And so what I need to do is I need to get rid of this positive 12 that's with the x, and I do that by subtracting it. So I'm going to subtract 12 to both sides. That 12 cancels out. I'm left with my x, and x is equal to, let's see here, 6. I have 6, I take 12 away, or I have 6, I owe you 12. You're going to tell me I still owe you 6. So I've isolated x and I've solved for it. There's no need to do the third step because x is by itself. So now I'm going to go and check this in the original problem. And again, we must check in the original problem. For now, all our numbers are going to be nice. We're not going to get any fraction answers. So everything should untie and work itself out real nice. So we have 2 is equal to 4 plus x over 3. But I have to now replace my x with a negative 6. So now I have 2 equals to 4 plus, remember, you use a parentheses, minus 6 over 3. Well, 3 goes into negative 6 negative 2 times. So now I have 4 plus a negative 2. I have 4, I owe 2, that means I have 2 left over. That 2 drops, and again, I'm left with a true statement. So my solution is x equals negative 6. And again, notice I just went sequentially through the steps. I'm answering the question. How do I know what to do first? How do I know what to do next? And we'll have this written down when we work on this. I'm not worried about you memorizing. I'm worried about you applying. All right, last problem. Last problem. 1, 2, and 3. 1, 2, and 3. Now this one's a little tricky. Okay? Now I want to point something out. It either cancels or it multiplies. It can't do both. And I'm referring to the first step, eliminate fractions by multiplying everyone by the denominator. I have a fraction, so I need to do step 1. So I'm going to multiply everybody by my denominator, which is 2. This gets a 2, and this gets a 2. Common mistake that I'm going to see is I'm going to see you guys put 2 of these over here. But 3 over 2 is just one number. And so remember, you get to multiply everyone by the denominator. You don't multiply numbers multiple times, just multiply everyone by the denominator. So we're doing step 1, we multiply everyone by the denominator. My 2's cancel out, and I'm left now with 3 is equal to 2 negative 6's is a negative 12. Step 2, can I add or subtract away a number from the variable side of the equal sign, meaning I have a plus or minus between the number and the variable. There's nothing between the number and the variable, so I can't do step 2. Which means I have to do step 3, which is divide away the number from the variable side of the equal sign. There's nothing between the number and the variable. There's nothing between the 3 and the x, so that's the number I'm going to divide out. So those 3's cancel just like those 2's did. 3 goes into negative 12, negative 4 times, and x is equal to negative 4. So now I need to go back and I need to check my answer here. So let's see here. So again, I'm going to write my original equation, which is 3 times x divided by 2. Does that equal to negative 6? Well, my x value is negative 4, so I'm going to get 3 times a negative 4, and then I'm going to divide that by 2. Is that equal to a negative 6? 3 negative 4s, that's a negative 12. A negative 12 over 2, that's let me pull this up a little bit higher. That's a negative 6. And negative 6 is equal to a negative 6. Again, this is true. So I have a solution. And before I go on any further, I want to make sure I didn't go off the screen. Oh, I have plenty of room. Okay, good. So again, this is just a demonstration of me using the 1 steps that we've learned about, solved by multiplying, adding or subtracting or dividing, and we put it into sequential order. So now we can solve 2-step problems. All right, and again, notice I wrote 1, 2, 3, 1, 2, 3, 1, 2, 3, and I worked my way through the steps. And when I did, I got answers, and this is hopefully giving you some confidence that I can answer that question. How do I know what to do first? How do I know what to do next? All right, so I'm going to go ahead and end this here. I hope everyone's having a good day out there. Have a good day, everybody. Bye-bye.